Welcome in the arena. My name's Allison Klein, and we're coming up on the AI Infra Summit in San Jose. I can't wait for this conference. It's going to be fantastic. And to set the stage, I've got a really special guest, Mohamed Awad of ARM, with us. He's a keynoter at the event and a fantastic leader in the silicon industry that is driving incredible innovation in AI. Mohammed, welcome to the program.
Thank you. That was quite the introduction. Thank you.
Well, I think you're deserving of it. Just to set the stage, this is the first time on Tech Arena for you. So you're the senior vice president and general manager of the infrastructure business at ARM, and you're responsible for such a broad portfolio across cloud, data center, network, AI, and HPC. Why don't we just start with a little bit about your background and how you entered this role and how you view your purview at ARM?
Yeah, it is really interesting to be in the semiconductor industry, kind of here at ARM. Real quick, my mom spent 30 years in the semiconductor industry working at TI, and I used to always say I never want to be there, and here I am, and enjoying it quite a bit. I went to school for software engineering. When I first came out, I worked at companies like Nortel and Lucent, kind of in the infrastructure space. Prior to ARM, I spent a decade at Broadcom in various different roles. Obviously well known for a lot of the for their semiconductor capacity, and then been at ARM now for 7 years. So it's been quite a ride, and having a lot of fun within info.
During that 7-year tenure that you've had at ARM, there's been a massive disruption in the data center market. I spent the last couple of decades in data centers, and, one of the things that I think about is that we've moved from the rack 'em, stack 'em commodity server market to one where racks of technology are being designed uniquely for AI workloads. When you think about what major cloud providers and neo cloud vendors, for that matter, are delivering in terms of core capabilities, what are the patterns that you're seeing, and how is the silicon industry central to that effort?
Yeah, I think you hit the nail on the head when you know when the cloud industry was born. It was born of, hey, we're going to take a bunch of commodity hardware and cobble it together and provide massive amounts of compute based on. Everyone's heard the story about how Google started in a Stanford dorm room and off the shelf silicon and hardware. I think what's changed over the last certainly several years, but if may probably 10 years or more, is that the world has adopted the cloud much more broadly. The amount of data flowing into the infrastructure, the amount of data being pushed out of the infrastructure, has really meant that cloud service providers have had to find a way to sort of scale to kind of keep up. And and scaling to keep up is both physical scaling, like how fast can I build another data center, all the way through to how do I find enough power to be able to support this and enough compute. And I think that's really been the big transition. And of course, all that's been incredibly exacerbated in the last couple of years through AI. That transition has made them really look at how to get as efficient as possible, how to get as much performance as possible out of every watt that they have available to them. And I think that's where um, you know building your silicon around your data center, i.e., doing your own grounds up silicon design in support of a system architecture or a data center architecture that you're trying to achieve, has really become the de facto standard, as opposed to the other way around, which was, hey, I'm just going to build my data center around whatever silicon is available. I think that's really been a big change in the industry, and we're seeing that happen even more aggressively as you move forward. There was commodity servers, and then there was specialized servers, things like DGX boxes. Today, we talk about AI factories, these full-on racks that have been designed. The networking and the compute and the acceleration has been designed very closely together to kind of enable optimal performance and efficiency.
So let's go back a few years. Think about the moment ChatGPT came out, and I think everyone realized, hey, this is a new moment of technology. This is something completely different than we've seen before. But I don't think anybody really understood at that point how big this was going to get. And I guess one question that I have for you as you look at the broad proliferation of AI factory build out is how big of an opportunity is there in front of us? Like, if we look at the next few years, how is ARM positioning itself to guide the industry towards making smart investments during that time?
Yeah, I mean, the sort of scale of AI is it's really kind of wild when you think about it. I mean, I saw, I've read, statistics about how there's gonna be 6.5 or $7 trillion worth of investment in infrastructure by 2030, just in support of AI. Or you look at how much compute was required or how much data was required in order to train GPT-4. It was a petabyte worth of data, right? So this is the sort of amount of data is just sort of staggering when you sit back and sort of think about it. Um, for our part, what we focus on is the sort of efficiency associated with enabling folks to build systems which are optimized for their problem set. And so that's really means a couple of things. I mean, first, it means driving an incredible level of performance. So that's kind of what we focus on is that perf per watt, credible performance in an incredibly efficient envelope. And of course, ARM's heritage has been efficiency. That's what we're very well known for. We've got a long history of 35 years of being kind of the platform around efficiency, but it's not just about the efficiencies of the CPU, it's the efficiency of the compute subsystem, it's the efficiency of all the other IP that's required to pull that together, things like our mesh networking, our mesh interconnect between the CPUs, et cetera. Um, but beyond all that, it's the efficiency associated with allowing our partners, in many cases, all of the large hyperscalers to go off and build silicon which is specifically optimized to their use case, which is designed around the acceleration that they're trying to achieve, the workload that they're trying to create. That's kind of what's very uniquely ARM, is that we give you that flexibility to go off and innovate. We enable you with that kind of technology leadership, and then we provide that ecosystem, or of course, we've got that incredible ecosystem standing behind us that you can kind of take advantage of. And I think it's the combination of those things which is allowing our partners to go innovate in these incredible ways to kind of meet that challenge.
We talk a lot about different trends in AI and what's happening in terms of the change of composition and infrastructure. But one of the stories that I don't think has gotten as much attention as it deserves is the remarkable growth that we've seen in segment share for ARM in the hyperscaler market during this time period. You've stated that you're forecasting that half of the compute shipped to top hyperscalers in 2025 will be ARM based. What do you think has prepared the company to take advantage of this moment of the AI era and drive new leadership into the space?
I mean, this is a classic case. Yeah, it's an incredible, exciting time. I mean, AWS talks about how 50% of the compute they've shipped in the last 2 years has already been ARM based. So now we're talking about, the other major cloud service providers kind of joining those ranks. And, this is, it's an incredibly exciting time for us from that perspective. This is really driven by a couple of things. One, as they achieve better and better TCO from these solutions, which are optimized for their infrastructure, better perf per watt across the board, that kind of high performance, low power consumption solutions, it becomes clear to them that that's the right path to go down, and that's the right avenue to deploy. And so we're kind of riding that tailwind on one hand for sort of just broadly general purpose compute, but now with the inflection of AI and these full on systems which are being, racks and systems which are being built specifically for AI, whether from NVIDIA or from many of the large hyperscalers, they're building CPU, GPU acceleration all together specifically in service of this massive influx of AI systems. Um, and so that's what's driving a lot of this. It's really about them seeing the sort of benefits that ARM brings to the table and taking advantage of it. For our part, and for the ecosystem's part, ultimately what this means, and I think this is the really interesting part of this, is that you've got this massive, amount of AI software and infrastructure which has been being optimized for ARM and being optimized for ARM first, whether you're on, a Grace platform or you're one of those homegrown platforms at one of the hyperscalers, it's all being optimized for ARM first. And I think that's an incredible place to be. We went from in general purpose compute where at one point we were, trying to get the software ecosystem to the point where it was as good as, and now, whether it's general purpose compute or AI, in many cases, it's software is being optimized for ARM first and not second. That's the big transition that we're seeing happen right now.
Another trend that I wanted to talk to you about is that we're entering the gigawatt era in terms of power consumption. Hyperscaler data centers are continuing to scale. And one thing that I know about ARM is, and you actually talked about it earlier, that you guys are known for compute efficiency. I think that energy efficiency and delivering of platforms is becoming pretty much non negotiable in AI, given the pure demand for compute. How is ARM helping address this challenge? And within the way that you're evolving your technology and working with others to deliver solutions to the marketplace?
Yeah, I mean, in the most basic way, it's like if you can, we obviously have a long heritage as we talked about earlier around designing, both CPUs and peripheral IP, which is designed to be incredibly low power. So that's the first thing. And just to put that in perspective, when you're talking about, a 500-watt CPU, if you can pull 20-30% of the power out of that CPU, it may not seem like a lot, for, a single CPU. But when you start multiplying that across an entire data center, that means a lot more AI you can fit into those platforms. I mean, the reality of it is that the world is struggling to keep up with power today for AI. And so getting more efficient on something like your compute, your general purpose compute, is not going to mean that you need less data centers. What it's going to mean is that you can fit more compute into that existing shell, which is going to be there for 15 years, or into that existing power budget that you've already got defined for that system. And so that's kind of where we come in, which is just helping them pull that overall power consumption down on some of those components, which ultimately drives a much more efficient system design.
Now, we've been talking a lot about hyperscalers, but of course, enterprises today are running workloads across multi cloud into on prem and then even to the edge. And moving workloads across this seamlessly has historically been a challenge. How is ARM addressing that need for workload portability across such diverse environments?
Yeah, it's a great question, and I'll tell you, it's really interesting because one of the unique things about ARM is that because our ecosystem, if you look at AWS, you look at Google, you look at Microsoft, you look at those kind of cloud service providers, they're all building, you know, bespoke custom silicon for their infrastructure, but they're doing so based on our CPU implementations. And because they're based on our CPU implementations, the software that's optimized for one can be leveraged across all of them, right? And I think that's an important point that maybe sometimes people miss, and that allows for those enterprises to go take advantage of all of the benefits, TCO and power benefits that oftentimes these hyperscalers pass along to them. They all sort of boast about 40, 50, 60% perf per watt or perf per TCO sort of benefits associated with their ARM-based solutions, and that's obviously a great place for the broader ecosystem to go take advantage of ARM.
One topic that I really wanted to talk to you about is silicon customization. And, I know from being in the silicon arena for a long time that when you can actually customize silicon to address specific workload requirements, you're going to end up with either a more performant or more efficient solution. I think that this moment is really a renaissance in a way of custom silicon delivery. How do you see ARM playing in that space? And how do you work with your ecosystem to support this?
So, so there's lots of things. I mean, obviously our focus at ARM has always been about how do we enable our ecosystem to go off and build the most optimized, most efficient, most performant systems possible. That's kind of what the company was born on back 35 years ago, with starting with the Apple Newton, right? So that's literally always been our genesis. I think, for our part, today, what we're doing is moving even further down that path by enabling things like our ARM Total Design ecosystem. So this is about, hey, we'll take a compute subsystem where we'll stitch together a lot of the CPUs and interconnects. We'll provide that to the ecosystem so that they've got a starting point. They don't have to start with just a bag of IP. That helps accelerate their time to market. That helps lower the overall investment it's going to require to achieve that custom solution, allowing more and more companies to participate in the design of products based on ARM. The other thing that we've done with our ARM Total Design ecosystem is we now have an ecosystem of partners who are now engaged with our compute subsystems. And so these are IP vendors who are taking their IP and integrating it into our compute subsystems. So if you need you know, a memory controller or a PCIe interface, you can go to one of our partners, whether that's a Cadence or a Synopsys or others, and they've already got it pre-integrated and ready to go on our compute subsystem, so further lowering your cost. We've worked with our EDA tool vendors so that they've integrated compute subsystem directly into the EDA tools to help streamline the development process. We're working with all of the major foundries, whether that's Samsung or Intel or TSMC, where they have used our compute subsystem to help go do uh, performance benchmarking and optimize their process nodes around it so that they're sure that, you're confident in what sort of performance you can achieve. These are all the things that we do through our ARM Total Design ecosystem and our ecosystem more broadly to go accelerate and streamline and shorten that cycle of what it takes to go build silicon, shorten the sort of overall investment.
Now, I know that we started the conversation here, but I do need to ask you, you're keynoting at the AI Infra Summit this week. What can attendees expect to hear about from you and your keynote? And are there specific messages that you want to send the attendees on the imperatives for what the industry and customers need to do together moving forward?
Yeah, I mean, I think I'm very much looking forward to the keynote, and I guess what I would suggest that the industry needs to sort of remember is that we are at the beginning of this renaissance, as you might say, and then a lot of it is being driven by just the sheer demand and the transformational nature of AI. And if we think about aspirationally what we would like AI to achieve and the potential for AI, I think it's clear that no one organization, one company, one technology is gonna be able to solve that all by itself. And so it's incredibly important that we collaborate together and look for ways to kinda advance for the common good so that we can all benefit from the sort of potential that AI is bringing to the table.
That's awesome. Well, Mohammed, I think your mother would be proud of you for actually choosing the silicon path because it sounds like your work is having a very wide impact on where the industry is headed at this very important technology inflection point. I'm sure that folks who are listening online want to engage with you. Where can they connect with you to continue the story and find out more about what technology ARM is delivering for these important workloads?
Well, of course, I will be at AI Infra Summit, so I'd love for folks to come say hi there. But if I miss you there, I'm obviously on LinkedIn and all the typical platforms. So please feel free to reach out. I'd love to connect.
Fantastic. I can't wait to hear your talk. I'll be there, and I'm sure that a lot of folks will be chomping at the bit to hear what you've got to say. Thanks so much for your time today, Mohammed. It was a real pleasure.
Thank you.